Hey everybody, this is Larry. This is me doing day 14 of the Leetcode daily challenge. Hit the like button, this is having some issue where, hit the like button, hit the subscribe button, join me on Discord, and let me see if I can figure it out. What is going on? Does it work for other problems? No, that one worked. It is very odd. It's a premium question. Okay. So maybe, did they just like have a mistake or something? I don't know. Maybe they took a premium question for a thing and I haven't solved this one yet, so, and I would like to at some point if I could see the problem, but it seems like it's having some issue. And I guess I could type into it, but it won't let me choose a language, so I don't even know what. Yeah, unknown network error. Please reload page. Been reloading all day, baby. All right. Well, what I was gonna say is no bonus points or whatever. What I was gonna say is that we're doing day 14 of the January Leetcode challenge, but I'm actually doing this in New York, which is January 13th to Friday. So, or Friday the 13th. I was gonna say, ooh, something spooky is gonna happen, but clearly, the spooky thing is that it's not loading. So let's see. All right, that loaded the top, but not. What is wrong with this problem? The other premium question seems okay, right? No, I don't know what I clicked on. But all right, let's refresh again. All right. This time it worked. Okay, sorry, friends. I mean, you know as much as I do about what's going on, but okay. So that actually works. Okay, let's actually take a look at today's problem. There was a premium question, so I don't know why they do it on a daily. Maybe they picked it by accident, and that's why there's a lot of weird issues going on. Yeah, hope they fixed it for everyone else. But for now, I'm gonna take a look at it because I haven't solved it yet. Today's problem, and I am gonna actually do an extra bonus question after this because I'm trying to catch up a little bit with, I don't know, doing all the problems eventually. Maybe not today, but so yeah. So definitely stay tuned for that as well, and hit the subscribe button and the little bell if you wanna. If this problem was too easy for you, or you can't even see this problem, then maybe we'll check the other one as well. People on my Discord actually now are starting to say that they're having issues loading, probably because of stuff like this. So yeah, so we'll see. Anyway, today's problem is, sorry for the long intro, 1061, lexicographically smallest equivalent in string. So okay, what does that mean? You're given two strings of the same length, and you have a string base string. So okay, S1, so basically they're equivalent classes, so A is equal to C, B is equal to D, and C is equal to E. Are they all mutually exclusive? Okay, so there's reflexibility, symmetry, transitivity, so okay. Return the lexicographically smallest equivalent string of base string by using the equivalent information from S1 and S2. Okay, so basically we have the input is given to you in a really weird way. Basically, you have two strings. Really, it's just a mapping between P and M together, saying that now we have one super string together. A and O is super string together, and then try to minimize the each of these. There are probably a couple of ways you can do this, and maybe this is also one of those problems where if you're not careful, if you're very clever but you don't know all the literature, you may reinvent union find by accident, which is actually not bad and pretty cool. And let's do that. I mean, I wouldn't say we are going to reinvent union find, but let's kind of do that without using the union find. Let's try to do that without using the union find vocabulary. Let's actually just do it from scratch and then think about how you would do it if you never heard of union find, right? And then a core part of this is going to be greedy, right? Because basically you think, okay, so there's P And also note that because all you really need is a transitive closure. You don't really need union find, and because the alpha, the size of the alphabet is 26, so you can do something 26 cubed with the Warshaw algorithm, for example. So there are other ways to do it, but let's kind of play around with this, right? And the core idea is going to be greedy because, for example, you have a P, you want to see, okay, what is the minimum character that is connected to, right? So basically here, we can start by saying, ooh, I hit the wrong, I locked my screen by accident. I thought I have a thing for it. Okay. So maybe I wouldn't call it parent because I'm still thinking about union find. And here maybe we can play around with this is how you would, reinvent union find. But basically smallest is equal to an array, right? And then just for x in, how do you say it? I forget what the string is called. Hang on. It's like string dot lowercase alphabet, or like ASCII something alphabet something, right? Let me Google this for a second. This is something in Python. You could probably just do it with a for loop if you actually are reasonable and you're not like me and trying to learn something. But for example, you could do something like this. And I'll show you what that is for a second. And it is kind of what it actually sounds like, to be honest. Basically, it just prints out A, B, C, D, E, F, G, blah, blah, blah. And you could do it with a range from 0 to 26 or something like that. And I usually do it that way, to be honest. But I'm trying to learn a little bit as well. So then now, smallest dot append x, right? Or maybe we'll do it with a lookup table. So then this is even more clear, right? So what does this mean? This means that the smallest that you can connect to x is going to be x, right? Yeah. So, and in the beginning, obviously everything is connected to itself because that's the smallest character that it can go into. So A is going to be A, B is B, C and C, dot, 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 right? So then now we do a for A, B and SIP. Is it SIP or SIP? I always forget. Basically now we put them together, and then now we're trying to, in a greedy way, just be like, well, if, oh, there's an extra comma. If A is greater than B, how do we want to do this? Have to be a little bit careful because I don't think that's sufficient. But basically, okay, so then maybe another way to think about it is the smaller is equal to the min of smallest of A and smallest of B, right? And basically what this is saying is that, okay, let's take the smaller that we can both reach, and then now let's update them both to be smaller. Of course, this isn't going to be sufficient, by the way, and I know that. I just want to make, just to be clear, and I guess we could have made this one line, whatever, it's fine. Because, for example, you can imagine that we set, I don't know, let's say you have x and y, you set f of y is equal to x, right? And then maybe you update another one, or maybe y and z first, right? And then you update to x, and then now you update y and z, or something like that. There's some like weird thing that you want to do, but then now f of z is, or f of y is equal to x. Actually, that works, but there is a way in which I'm trying to think. I'm really maybe D and E first, so then I could add stuff later, and then say F and G maybe, and then now which F is first, right? So G is equal to F, right? And then now you combine D and G. Well, now you're going to update f of D, or f of G is equal to D, kind of, right? But then now, if you're not careful, that means you haven't updated f of f, right? Because f of f is still f, even though now they're all connected, kind of thing, right? So we have to be careful, and there's stuff like this, but you know, it'll get us a little bit to kind of to begin. Is that sufficient? Maybe I'm doing this in a weird way because I'm trying to avoid doing union find. If you already know union find, maybe you should just do it union find. But I think what I want is actually the smallest not of A, but the smallest of A is equal to the smaller. I think that makes it okay. Maybe not still. Maybe I'm doing this in a weird way. Because basically what you want is basically you want to travel through the entire tree so that this is kind of hard to do without quote unquote without the restrictions that I impose on myself about union find, but because everything I want to do is just ends up being union find. Yeah, maybe that's it, right? So that here, because smallest of A in this case is not necessary to be updated, right? So what we want to do is maybe set something like, yeah, and we'll have a helper function here as well, just like get smallest of X, right? And then basically if smallest of X is equal to X, then this is over, then you don't have to keep going up. That is the smallest, right? So then you return X. Otherwise, we want to get the smallest of X. We want to update this to we want to update this to we want to update this to kind of go forward to the parent. I said parent, but basically, you know, if we have G here and we're trying to go up to D, then now we should update D as well. Actually, sorry, if we're getting F, when we update G, we actually also want to update F as well to update F to already update D, right? So that's basically the idea of what we're trying to do here, almost like a tree thing. You don't have, you could do it without actually this thing. So you could actually just do something like this where you return the smallest, and then that would work. So what we have here is that we also update it, and in union find terms, that's actually called path compression. So in case you're wondering, so yeah, smaller is equal to maybe min of something like that, right? And then now you want to update both side to the smallest thing that you can get on both things. I think oops. And here maybe you could draw it out a little bit. Yeah, I mean, I think if I was doing it at home, I would advocate just writing it out, what you're doing here and updating. But also, honestly, I think I'm giving up a little bit. I think it's kind of hard to rederive union find from first principles off my head. I mean, it's tough. It's tough, especially to understand the complexity or time complexity and stuff like that with path compression and stuff. So I kind of was a little bit over ambitious here. But so the short answer is to read up on a union find data structure, or I think that disjoint union set. Wait, no. TSU, what disjoint set union data structure, and maybe the other thing that you could do is transitive closure, which is solved by Warshaw's algorithm, right? Which we did not do here, but it would also be like a 10-line solution actually, so it's kind of bad on that point. But yeah, after you do all this, now, you know, for each character in base string, all we have to do is get the smallest of that string. And that's pretty much it. And then join it back into a string from an array. Yeah, that's pretty much it. Let's give it a submit. Hopefully I didn't miss anything. Cool. Yeah, I mean, this is basically, you know, if you believe that, and I'm not going to derive it, but if you believe it, this is actually amortized constant. If you want to debate whether the inverse Ackermann function is constant or not, that's up to you to do on your own time. But for me, it's going to be constant, and so there's constant of operation, which is in terms of n, which is the size of the unions. And here, this is also O of 1 lookup effectively, you know, so yeah. The other thing that you can do, as I said, is, so this is the solution of union find. Pretty straightforward, to be honest. If you know union find, if you don't, it's kind of tricky, but like I said, it's simple enough that in theory you could come up with it. Another thing that you can do, as I said, is transitive closure. Since I kind of, I don't know, messed up the other one, I am going to maybe do a bonus code solve with Warshaw's algorithm. And then the idea here is just having whether A is connected to B for, or, you know, for any two characters, right? So then now you can maybe say it's like connected is equal to force times 26 for 26, something like that, right? And then now, I think there are two variations. You can do it with or without it, and then yeah, and then you could do something like for I connected I is equal to true. I mean, we could also did a two-dimensional whatever, but maybe it's fine. Yeah. And then now for everything, every time that we connect it, we have in I1 is equal to right, I2 is equal to right, and then this part is simple. Now you just, you know, mark them as connected, and because they're symmetric, you could also do the other way though. Actually, I don't know if it matters. I don't remember all the Warshaw algorithm things anymore. You may also see some people refer to this as Floyd Warshaw, which is technically not quite accurate, but it's the same idea though. And then yeah, and this is just like I said, Warshaw's algorithm, and then basically it's actually a dynamic, considered a dynamic programming problem. So definitely check that out. This is actually wrong, so don't hang on. Is this, or does that work in Python? Right, and then here now you can and maybe we can implement another get smallest just as a helper, and then now it's just for I in range 26. J is equal to, and then if connected from I to J, then we return I kind of, but we have to convert it back to a character. Right, and then else, we should throw an exception, right? I mean, I'm asserting instead, but yeah. Give us a minute. Don't know if it's faster. Is it faster? No, it's much slower. I mean, you know. Yeah, and this one is going to be alpha cube. Is one of the complexity plus linear plus linear. You could probably cache this. Like you could probably just run it once for 26 square. I'm a little bit lazy, so maybe that part is a little bit lazier. Because you only have to run it once for every. Yeah, I mean, if you run all the entire thing, you cache it, right? So yeah. Anyway, that's all I have for this one. Let me know what you think. Let me know if you have any issue just even opening it, because silly Leetcode. But that's all I have for today. So let me know what you think. So stay good, stay healthy, to good mental health. Have a great rest of the weekend. I will see you soon and take care. Bye bye.